Students, this video is going to go over section 3.9 for Math 3. Yeah, we've done all of chapter 3, and it's quite a dense chapter. The whole chapter is about polynomials, and you'll notice they go through polynomials, 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 polynomial, polynomial, polynomial. It's all throughout the entire chapter, except for the fundamental theorem, and that also happens to be about polynomials. They just didn't use a word in the theorem. Anyways, we're going to take a look at 3.9. What's the difference? Well, the difference is graphing a polynomial function, you're usually given an equation. So if you're graphing, you can make a table of values and things like that. We're going to try and model equations. So what we're going to do is we're going to go backwards. Okay, so if I gave you an equation, okay, so if I gave you this, we could graph this. One way is a table of values, but it would take a long time because you need a lot of points to really see all the parts of that curve. Okay, so before we do that, we'd want to try to factor it, we'd want to try and divide it, and all that good stuff. That's not what we're doing in this chapter. This section, we're going backwards. We're saying we know the graph goes like this. Okay, find me an equation. Okay, so we're going to find, in fact, we're going to use this one right here. I'm going to make up some points right on the spot. I'm going to say -1 it goes through, and it also goes through +1, 2, 3, 4. Okay. So we just drew this curve. I just drew this curve and established that it went through 3 points on the x-axis. Okay. These are called zeros. They're called roots. They're also called x-intercepts. And I like that name because it explains what they are. They are x-intercepts. They are points on the x-axis. So how do we find an equation that goes through there? Well, we're going to make it one little step tougher. Because if we want just this, we have a lot of information right here. We're going to go through one more point. Let's say we go through 2, -2. So how do we find an equation for this? Well, having 3 intercepts or having 3 zeros is critical. So I'm going to put 3 factors here. That's going back to that fundamental theorem. That's what the theorem tells you. If you have 3 factors, then you have 3 zeros. If you have 3 zeros, then you know you have 3 factors. You could have more than that, but let's just start here. Now the key thing is a little bit backwards. If your 0 is -1, then your factor is +1, x plus 1. Because this is the value that you plug in to give you 0. So when you plug in -1, that would give you 0. Okay. Now when it's 1, your 0 is not 1, it's x minus 1. Because when you plug in 1, that will give you 0. Same thing with 4. It's not x plus 4, it's x minus 4, because when you plug in 4, this gives you 0, the whole equation goes to 0. That's what we call them zeros. They quite literally make the entire equation 0. Okay, so this by itself would do that. Okay, but there's a lot of curves that go through these 3 points. I'm gonna sketch over my graph. Well, I can make another one that went up and even higher and totally missed the 2, -2, and then went like that. Okay, so we just stretch this, and that's what we're going to see on the graphing calculator. So how do we make sure that it goes through that point right there, 2, -2? Let me rewrite it. Well, this is just some random point. But every point is an x and y. Every point is an x and y coordinate. So how do I stretch this? Well, if you remember stretching parabolas, it's the same way. You use a multiplier. You use a number in front. Uh-oh. Wait a minute. We don't know what number. We don't know what number makes it hit 2, -2. So let's do this. Let's plug these in. I'm going to plug in -2 for y. I'm going to plug in 2 for x. Plug in 2 for x. Plug in 2 for x. So the x happens 3 times, and I plug in 2 for all the time. So replace this one with the 2, replace that one with 2, replace that one with 2. And the y got replaced with -2. Because of this point. They could have given us 3, 4, and we'd have to plug in 4 and a 3. They could give you 10, 17.8. Doesn't matter what point they give you, you just plug it in. We're using whole numbers just to make sure things work out a little bit nicely for our notes. But in reality, you could use any numbers, and you can find an equation. 2 plus 1 is 3. 1. Be careful here. That's a negative 2. So a times 3 times 1 times 2, that's 6. Actually, it's negative 6. A. Move this down. And again, we're trying to solve for a here. So divide, don't add 6. Divide by negative 6. And a equals negative 2 over 6, or that's the same as positive 1/3. All right, now I put a box around that, but that is not actually our final answer. Our goal here, remember, was to graph. What we did is we found the value of a. So that value of a is 1/3. Then we put in the rest of our equation with the x's. X plus 1, the x minus 1, x minus 4. That should be our final equation. That equation should make the original graph that goes through our original points. Okay? Now, there's not an easy way to check it unless you have access to a graphing calculator. The good news is we do, and we're going to use Desmos for that. So let's flip over to Desmos. Okay, I'm in Desmos now, and I've already typed it in. So there's our equation, just like we had from our paper. And sure enough, it does hit -1, +1, and 4. Now this point down here is some random point. We did not hit that point. We said we hit 2, -2, and it looks like it went through there. It looks like it went through 2, -2. But let's really make sure. What you can do is you can put on here 2, -2, -2, type right. And there it is. That is definitely right on the graph. That's definitely right on the graph. We hit that point. We hit our original points, 1, 1, 4. It's -1, 1, 4. And also through 2, -2. Alrighty. And so that's it. We did it correctly. We are happy. Now, I want to go through and show you one more thing, just because. I'm going to copy this whole thing and paste it here. And instead of the 1/3, I want to show you we could hit the same points, but avoid the 2, 2. So instead of 1/3, let's say I messed up. I said, oh, I thought it was 1/6. That's the same curve. It hits the same x-intercepts, but misses our 2, 2 point. It misses that. Okay. Let's say you messed up and you thought it was 2/3. Again, it's another curve that goes through the same points, but misses that 2, 2, 2, -2. So we can have all the same x-intercepts. Okay. As long as these factors are all the same, the intercepts will be the same. In fact, I can go and do this. I can put a slider here. We originally called it A. We can call it A. And we can stretch this thing way up. We can stretch it or shrink it. And the key thing to notice here is I'm stretching the graph just like we've always done, but the intercepts are staying where they were. So I can make it really skinny. I can make it go right on top there. We can get to anything you want by stretching this. And that's kind of fun. Okay, so now you see, with the factors you've created the intercepts. Okay? And with the value of A, you just stretch it. A is just a stretcher. Okay, it just stretches all the rest of the points. But A cannot affect the intercepts, because those are the factors. We're not changing those, we're just changing the stretch value. All right. By the way, the book will not call it a stretch. They will call it they will call it a vertical stretch. Or a vertical compression. So right now we are stretching it longer, and then right now what we're doing is compressing. And you can think about that. If we compress it really, really down, we should be able to make it almost flat. If you can get it there. If we get down to 0.1, that's kind of flat. 0.01, that's even flatter. So you control all of this. Okay, we got too many graphs on here, so let me turn these off. Oops, let's keep that one on. And I kept all the equations in there. I just left that. So you can control A by changing that. We point 0.7, that's more curvature. But the actual number 7 now is really stretched. And so again, you can play around with this. 1/7. You can put fractions, you can put decimals, you can put whatever you want. And again, it will still hit at -1, at 1, and at 4. And we are now at the end of the chapter, and you now know how to adjust and stretch polynomial curves. You are the master of polynomial curves. You can make it do whatever you want. You can control the x-intercepts. You can control the stretch. That's very powerful. So thanks for watching, and email me if you got questions still on the homework.